I'm Zach Kirch. So this is the first part of the Michelson applications lab, and this is measuring the wavelength of the extended mercury source. 1, 2.
To find the wavelength of the mercury source, we counted the number of ticks that passed when we counted 50 fringes, and our result was 526.015 nanometers. And then we used that to find the number of fringes that we would need in order to find a 0.1 nanometer error. And our result was 5,406. The lambda that we calculated was a bit low, and that could be due to the setup and miscounting the number of fringes from the detector.
This was the yellow sodium source, and we used the same procedure as the previous part to find the wavelength of it. Okay. 1, 2.
Using the same procedure as we did before to find lambda, we found that lambda was 585.34 nanometers, which is a little bit low. And then we also need that calculation to find our error in lambda. We did that by finding the null of the fringes where it disappeared, and then the second null, and we did that by...
And we used the calipers to measure the knob length, and then once we went from the first to the second null, we calculated the distance, and from the values we had, our delta lambda was 0.406, which is a little bit lower, but that probably was because our wavelength was lower and the error in our separation distance as well. So for the setup, yeah, we're changing the pressure, which changes the number of fringes, and we'll calculate the number of fringes that it goes.
For measuring the refractive index of air experiments, we needed to find our slope, and we did that by taking over the change in refractive index over change in pressure to be this given equation in our lab experiment, and we counted the number of fringes that went by as we changed from 56 pressure to 20 pressure centimeters per mercury, and then our D, the distance in the chamber, we measured out to be 41.32 millimeters. Using that equation, we found our slope to be around 4.04 times 10 to the negative 6.
And this is our graph of the 2 points here, and as you can see, the slope is very close to what we had calculated from the previous experiment. We also included the pressure of the room in this. So we measured the refractive index to be 1.0029, and that was after taking the pressure in the room, multiplying it by the slope that we calculated, and adding 1 to it.